Good evening, everyone. So welcome back to RoboCup at Home Education Online Classroom Open Platform. Okay, so today we enter the third class, and in this third week, we will share about robot visual perception. Okay, so about vision system, and welcome everyone, and I'm Jeffrey from RoboCup at Home Education, and together with me today, we have our LOC from RoboCup 2022 Bangkok, and also Jupiter Robots. Okay, so let's get started. So first, as usual, we divide this class into two sections, so A and B. So for the first half, we'll talk about RGB-D sensing. Okay, so basically to give you some idea how we get the image data from our sensor and then put into ROS and get ready for our processing. Okay, then for the second half, we'll introduce some Opencv application. As you know, Opencv is a very popular vision-based library that gives us a lot of very advanced tools, okay, to recognize face, to do some image processing, and so on. So on the second half, we will learn from the data that we obtain from the sensor, what we can do with it, okay? And also this application will be more focused on our application in at home or service robot development, because our purpose is to let you know some technique that we use in at home, and it will be very useful for you to develop your robots. Okay, so we will have two parts, and also today I also invited Jupiter Robot, and today we will see, okay, using the robots and using the sensors and what we can do with this system. Okay, right. So as usual, I put the 3 link there. So for any newcomer today, welcome to our class. So the first link will lead you to our homepage where you can find more information about this class series. So we actually have class almost every day in a week, different topic, different languages. Today we will have English, and also we have Thai support, right? Thai language support, because majority of our audience today coming from Thai, right? So so for our Thai community, feel free to discuss with us, talk to us, and interact with us. Don't worry if you don't speak English well, because our local community member are here to help you, right? Okay, so feel free to express yourself if you have any question, and but of course we will have time for Q&A, right? So as you can see, we are going to start from 7:30. And then we will have the first half for 1 hour, and then roughly, and the second half for another hour. But in between, we'll try to have some Q&A session, okay? So of course, you can keep your question until the last, which is we have a longer time for us to discuss. But in between, yeah, don't worry, you can actually have time to ask us any question, right? So we really want to know what is your interest about the things that we deliver, so that we can actually position the delivery to something that is more relevant to you. Okay, so feel free to interact with us anytime in the whole session. But of course, due to privacy concern, the whole session will be recorded, and we will upload this video to our website and also social media, YouTube and so on. So for other time, I mean, like other than the Q&A time, so please try to keep your microphone and also your webcam turned off, okay, so that you'll be not recorded into the class session. But of course, again, we are not stopping you from interacting with us, so we will have Q&A session as by time, all right? Okay, so please stay with us, and we will interact along the way, right? Then you may ask also, like, so where is this video? So as I explained like last week, so we will try to put up the video 1 week after the class, which means now last week class we try to put up on the website. So the website is RoboCup at robotforall.net. Okay, so over there you can find the PowerPoint slide that in front of you. So the slide in front of you, you can find over there, and also the video, right? So after a week, the video will be there together with the slide, so you can refer. You just go there, sign up an account, and just enroll the class. Okay, so this class is free, and don't worry about that. Okay, then if you have anything you want to discuss, of course, you can discuss with us during this session, or you can go to our class group. There's a forum there that we can use for discussion. Okay, so anything that you would like to discuss with us regarding the class and also regarding the competition, feel free to contact us, and also feel free to discuss in forum. Right, so that's all for the logistic arrangement for this class, and we are going to start. Okay, right. So I hope everyone already settled down, and I can see the list is yeah, almost everyone is in. Okay, so for today, for visual perception development system, again, we require very minimum hardware and also software for you to start this development. Okay, because this class is meant for the general public. So anyone without we don't concern any of your background as long as you're interested in building robots and learning AI. We will try to design this class to use very common material, okay, for you to start. So for example, today we are talking about visual system, okay, visual perception, okay, vision system. So you can find camera anywhere, right, in your laptops, and you've got webcam, you got USB camera, your phone, okay, and other things. Okay, you can find camera easily everywhere. So for this class, the content we design in such a way that you just need a USB camera. Okay, it is a very cheap hardware that you can obtain anywhere, and plug it USB plug to your PC and it should work. Okay, so we need a laptop, the development environment that you already set up like in the first week. We need the Ubuntu system they're running for as the operating system, and then we have the ROS framework within the running on top of the Ubuntu system. Okay, so that is the development environment that we need. And later on, we will introduce you the related component software, for example, the Opencv and other things that we need for today's development. Okay, so for the hardware, we will try to use most of the time use the USB camera as the reference to show you the example. But of course, we have some other example that require a little bit different sensor data. Okay, so for example, today we introduce you the Rgbd sensor, which is we have the distance sensor within a camera. Okay, so the distance sensor or the depth sensor will give us the range data that we can use it for more how to say, a different way of visual perception that we will show you some example after this. Okay, so over here in this today's class, we will use the Opencv Astra, which is the typical RGB sensor for Turtlebot 2, and also the previous sensor, which is a Microsoft Kinect, but currently I think like it's already like out of the market. You cannot find it anywhere, but they work in the same principle. But of course, whatever that I show you, it also work with other RGBD sensor. For example, if you have Asus Action Pro Live, that one is also RGBD sensor, and it works almost similar. It's just that the driver that you put in to run the sensor is a bit different, so you need to get the correct driver. But how it works is supposed to be the same, right? Almost the same. The example should be compatible with different kind of RGBD sensor. And one more that recently most of the people using is the RealSense, Intel RealSense. Okay, so the RGBD sensor that I mentioned just now, you can use. Okay, any of the RGB sensor that you can use. Of course, the latest one from Opencv kit, that one we are not so sure because like we never tried before. Okay, but if you have that sensor, yes, feel free to share with us your experience of using that. Okay, so we are giving the example that quite general and universal for most of the RGBD sensor that is popular in our community. Okay, so today the hardware is just a camera, and we will show you some more a little bit advanced RGBD sensor and also your laptop computer that run the software that need for today's development. Okay, so these are all the things that require to follow today's class. So I hope if let's say you have joined this class for the previous 2 weeks, you already know the basic, you have your system set up, and you are quite familiar with ROS. Then it will be very easy for you to follow the class with it. Okay. All right. So first thing, a very brief and general introduction about robot vision. Okay, so robot vision, we have using a lot of optical and camera-based system. Okay, so most of the case we use the optic phenomena or the optic fundamental concept to develop this kind of sensor. Okay, and over here you can see like two purposes. One is to get the distance. Okay, so we have a laser rangefinder. Laser rangefinder is quite popular in mobile robots because like it is used even before camera in on a robot or mobile robot to find how to say, to map the environment so that the mobile robot can move around, right? So laser rangefinder is kind of like very matured and also very popular technique in mobile robot or popular devices in mobile robots that use for navigation. Okay, then also of course similarly to laser rangefinder we have but using a different concept, for example like ultrasonic distance sensor and so on. So and then today we have the LiDAR and radar and so on. So all are using the wave to get the distance. Okay, right. So this one is to get the distance. And then another one is we using color sensor. For example, the color camera. So we have the CMOS system, the CMOS sensor, and also the Ccd sensor and so on. So these are the sensors that sensitive towards colors. So we get the colors value, then we have the color data. So with this color data, we try to do image processing in order to understand what is happening in the surrounding. So over here, you can see we have various type of robot vision sensor that work on this principle. So we have like from the laser rangefinder, and then we from one plane or one line until like 3D or more common one in 2D, because like mobile robot, we always work on a flat surface or 2D plane. So 2D laser rangefinder is very popular in mobile robots. Then we have the color camera, which is very, very popular because of we have camera almost like on every single cell phone and so on. So color camera, you can get it anywhere. And it works with very big system and also very small system. You have very sophisticated camera. You can also have very, very simple camera that is very, very cheap, okay, that you can put a lot on the device. Then we also have the combination between distance sensor and also color sensor, which is we have the Rgbd sensor, okay, on the lower right hand side. So that is the Rgbd sensor. So that is the Microsoft Kinect sensor, which is a combine the color sensor pair and also the infrared depth sensor pair. You over there you can see like a IR emitter and also a receiver, a depth sensor, and then we have the color sensor. So it combines RGB, which is the color, and D is the distance sensor. Okay, so these are the sensors that we concern in our robot development. But of course, there are actually many others sensors, but these are the popular one, which is very common when we want to develop this kind of robot application. Okay, so some working principle for this Rgbd sensor, because we use Rgbd sensor a lot. Okay, we use it for our navigation, we use it for our human perception, we use it for our object detections and so on. So we use a lot, right? So one classic example is the Microsoft Kinect sensor. Okay, so this one is a very, I can say, game changer, right? So before this Kinect sensor was introduced, we actually have very, not to say, it's not easy for us to get this kind of result. This kind of result means we have the color and also the distance that is fusion together, this kind of data. So this kind of data is very useful for our visual perception. Okay, because of the very rich and also accurate sensor data that we can do a lot of image processing in order to understand what's happening in the surrounding, right? So previously, yeah, a lot. Like for example, I still remember I worked on stereo vision, and it's very expensive setup. It was a very expensive setup in order to get the same result like from the Kinect sensor. So the Kinect sensor is a mass-produced sensor that it really like bring down the cost to very low, and yeah, it helps the robotic community to use this sensor for a lot of applications. So over the year, you can see like now it is very common in various kind of robotics application. Okay, so for this Rgbd sensor. So in this Rgbd sensor, we have a RGB color VGA video camera. Okay, so we have a color camera, video camera. Then we have the depth sensor, which is over here, because of the cost, it need to bring down the cost. So instead of using laser, it is actually using an infrared. Okay, infrared projector. So projector is like in a 3-dimension. It's not just one line or plane, but 3-dimension. And then it has a monochrome CMOS sensor to actually get the reflection. Okay, so that is actually one is the emitter and one is the receiver. Right. And yeah, you can see the resolution is not so high, but this resolution is good enough for image processing. Okay, because we need to perform the processing in very high frame rate. For example, like this sensor can give us like 30 frames per second. Although 30 frames per second is not very high, okay, but it is good enough for mobile robots. Okay, because like the mobile robot is not moving very fast, so 30 frames per second is actually very good enough. It's good enough. In fact, most of the cases, from my experience, we only run on about 10 frames per second. 10 frames per second, I think is good enough because you have 10 frames in 1 second. And even, for example, if you want to detect face, you want to detect hand movement, human, human activities or human motion is not that fast, right? But unless you are talking about, for example, self-driving car, which the car is like moving at the 100 km/h speed, then you need very high accuracy and also very fast camera and also very fast computational in order to get the very slight change or very fast change of the environment. But when we talk about service robot or mobile robot, we actually don't need to be that fast. So somewhere between 10 to 30 frames per second is actually good, more than enough. So that's why this sensor is developed, or the whole configuration is just enough and very how to say. Initially, originally it was used for the Xbox, which is a game application, which is to detect like human motion, and then you can for use to do the immersion type of game. But this application is also very matching for mobile robot application, especially for service robot that you want to detect like the movement of the human in the surrounding or detect some object in the surrounding, which is most of the cases not moving. Okay, right. So it is very suitable for our application. And over here, I would like to get your attention to look at the range as well, the sensor range. So because it is designed for us or for the consumer, for the game operation. So the distance is something like the distance you stand in front of your Xbox or your TV. So it is somewhere between 1 to 4 meters within there. The blue color one is the effective range. The total length is the total range, but the blue color one is the more effective one. Okay, so usually we try to design our application so that our target object or target person will move within this region, which is like from the camera up to 0.8 to 1.2 meters. Okay, so after that, and then within 3 to 5 to 4 meters. Okay, so this is the range, and also the height is about. If your robot is about 1 meter tall, then you put on top of your robots, then it can detect about a 1.8 to 2 meters height object. So which is very is within the range of a human adult. Okay, so this range is very suitable for our application in service robot development. Okay, so this is the design for the Rgbd sensor, and we are going to use this sensor for our class today to explain to you what kind of application we can build with this kind of sensor. But of course, again, if you don't have this Rgbd sensor, don't worry, because I think like more than half of the content today that we deliver, you can also materialize or realize, or you can actually develop with just your USB camera. Okay, but of course, if your USB camera is it work with a different configuration. For example, like the resolution may be higher or maybe lower, the frame rate may be higher or lower, etc., etc. Okay, and also one very big difference is your USB camera will not give you any depth or distant value. Okay, it only give you the color value, so you can only detect like in the images. Okay, so these are the different. Right, so from here, okay, so a little bit more about the concept. So distance sensing. So just now I talked about the laser rangefinder. So distance sensing, we're using the optical behavior. So we know like lights will actually move in a straight line from the source. And then once it hit on certain object, wall or any object, then it will bounce back, come back to the original point. Okay, so this travel, the light that travel from the source or from the transmitter over here, and then to the object, and then come back, and we have another one which is the receiver. So we can imagine one emit the light, and another one is a sensor that sense the coming back light. So this distant travel, we can use this phenomena or this physical behavior to measure the time. Right, sorry, to measure the distance by measuring the time, right? So the distance to the object is measured using the time, which is time of flight, the technical term TOF, of the laser beam emitted from the transmitter, hit the object and return to the receiver. And we know that this distance is like 2 times the distance, so we need to divide by 2. And we also know the velocity, because like the velocity is almost close to the speed of light. So with the very tiny speed change of the time, okay, but if we measure like a very big long distance, then the time will be slightly bigger, but still the speed of light is very, very fast. So this sensor is a very, how to say, we can have very responsive, which means it can give us the value or the result very fast because of the speed of light to measure the distance. Okay, no matter how far, right? It won't have any delay, almost won't have any delay, right? So this is the concept to this to measure or to sense the distance. So we use this concept to design or to develop the sensor, the distance sensor. Just now you have the laser rangefinder or the infrared. So they are all spectrum of light that work in the same principle. Okay. Then for color sensing, so how camera sensor work? I think this one you can get a lot of materials online, and in fact, I think like most of you already know, but just a brief recap on this. So we use the imaging element, which is the photodiode, right? So it will convert the light intensity into electrical signal. So this is the working principle of the sensor. And for this kind of sensing materials, we have either a CCD, which is a charge coupled device, or a CMOS, complementary metal oxide semiconductor. Okay, so a CMOS or a CCD sensor is something that will sense the light, that convert the light intensity into electric signal. Okay, so this is the sensor. Okay, and we have a lot of this photodiode that will have this behavior. Then, although it is good that, okay, so once it convert into electric signal, then we can measure the light intensity. Okay, but for color sensor, we want to know the difference between the intensity of red or a certain color. Okay, so for example, over here we measure using the red, green, and blue. So that's why we have the RGB sensor, right? So we use this color filter, which is arranged on top of this photodiode. So this filter will filter the light so that only allow red color or green color or blue color to pass the filter, and we have the sensor below the filter to actually measure the intensity, so that we know how strong is the red color, how strong is the blue color, and how strong is the green color. And with that, we can get the RGB value. Okay, RGB value is basically three value: R1 value, G1 value, and blue. So with these three value, we know the intensity of red color, green color, and blue color, and we merge these three color together, we get the color, right? We get the particular color at that particular pixel. And the color, the pixel, or yeah, just 1 dot over there is 1 pixel. So the value is measured between 0 to 255. So we have 256 level. 0 itself is a level, okay? So we have 0 to 255, 256 level. So this level will measure the intensity of red, green, or blue. And with this value, we know what is the color at that particular pixel. And you may heard also, like, for example, how many megapixel and all those things. So megapixel means like one photo, how many pixel you have. So that's why the higher the megapixel you have, your photo is more sharp, because like your point is getting finer and finer. So you can have very sharp photo. Okay, so that is the resolution, so on. Right. So there are a lot, like I'm just explaining this thing in a very layman and also general term. But there are a lot of things that you can read about this color sensing or how a camera works and so on. Okay, but today we are not going to explain or we are not going to do anything with this. But what we want you to know is we are going to use this RGB value to do something for our image processing. Okay, right. So this is just to explain where this RGB value come from and how our color sensing material or system actually sense this RGB value. Right. Okay, so we talk about the distance sensing principle and also the color sensing principle. So now let us come back to our topic, or come back to our problem. Okay, what is our problem? So in visual perception challenges, so which mean like what the problem that we try to solve, you can see the objective of our visual perception or the objective of our vision system is to understand the environment. Okay, the environment, for example, like in a service robot or in at home, we have a typical home environment, and home environment is a very colorful, very complicated environment. You can see a lot of colors. So if you compare these to, for example, a factory, okay, a factory which is like in a control environment, everything is very, how to say, structured and under control, and the lighting is very uniform. You don't have a lot of shadows and so on. But in a typical home environment, it is very harsh, because like you have like spotlight, you have like different lighting in different location, okay, because, and also different color. Sometimes you have the warm or yellow color lights. Sometimes you have a blue, a very white fluorescent lights and so on. So the lighting is not very, it's not very uniform. It is quite different. So some object under different lighting condition, it looks different. And also, there are many things in our home environment. Okay, as compared to in a factory, you have very clean environment. You don't have anything complicated there, and everything there is under control. So you know exactly like what the wall look like, what the floor look like, what the table look like, and it will be the same. Okay, it will be uniform. But in a home environment, not only you and your neighbor having very differently how to say, how you decor or how you arrange your living room will be totally different, and even your living room and also your bedroom and other room might look very different as well. So this kind of environment is very challenging for our robots. Okay, so for our robots, in order to understand the environment, so we need to understand the complexity, understand the changes, and also understand that different lighting actually makes something look differently. Okay, for example, you have an apple, but you put an apple under a yellow light and put under a white fluorescent light, the color look very different. Okay, and this will directly affect the quality of the visual perception. Then again, the typical object in our home environment is like many. Okay, we have a lot of object in a very small environment in our house, and also even the same object will have different packaging. For example, you have very colorful packaging, you have different wording, you have different, look very different. Like even like mineral water bottle, you got so many type of water bottle I mean, the same mineral water bottle can have very different label, different packaging, different bottle, and so on. So how robot want to understand they are all the same mineral water bottle? So these are all the challenges that we want to use our visual perception system to solve. Solve mean we need to make our robot able to understand or able to detect the object in the environment. So these are the challenges that we face. But later on, we will see how we can use our advanced technique. Okay, especially nowadays, we even use, like, for example, deep learning, machine learning to actually make our recognition rate higher. Okay, so we will discuss this in the second half. Okay, so these are the challenges, and we are going to discuss how are we going to solve this problem. Right. Then, okay, we understand the environment is very messy. Okay, it's very colorful and also very dynamic. Then for the task, we also have a very, how to say, complex task. For example, you need to recognize the face in this kind of environment where your background is your background is very colorful, and also you might have poster that have face there. So that is the challenges. For example, like over here, you have the t-shirt or the dress that the human wear might also have some design that will distract the visual perception system. Right. Okay. Then also we have a furniture, and also we have arrangement in the house that will also help or distract the vision system. For example, we have a cabinet that we can open and close, and that will actually affect the color, the lighting. Okay. So how you want to perceive all these things. So these are all the challenges, and the tasks can be very challenging in a home environment. So that's why if you are interested in vision system, home environment is very challenging for you to do your R&D. Okay. Okay. So I've spent quite a lot of time on the theory part. So let's start with the hands-on part. Right. So first is like we want to do robot vision with ROS. Okay, so over here we want to do it with ROS, and it's pretty much easier to do in ROS. Of course, there are many ways that you can do. For example, like you can do in Python, just Python and Opencv. So Opencv library is enough to do a lot of things. But in this class, we try to explain how you can do it in ROS, although some people might feel like it's more complicated, but it's actually not very complicated, because we have a lot of packages that will help you, okay, to pass the task between Opencv and ROS, because Opencv have very good integration with ROS. In fact, when you install ROS, you already install Opencv in there. So because we use a lot of Opencv in ROS, so the integration part is already there. And today we are going to show you some ready-made application. Okay, so over here, there are a few libraries that I'm going to introduce to you. First, before we talk about Opencv, because Opencv is already at the application level, so we need to start from the hardware interface level. For example, how you want to get your data from a more structured and processed data from your sensor. So, for example, over here we have the OpenNI tool, we have the OpenKinect, we have the PLC. So these are the library. For example, like OpenNI is the Open Natural Interaction, if I'm not mistaken, right? So it's a library for the Kinect sensor or for the RGB-D sensor. Okay. Then we have the OpenKinect, which is the open version of the Kinect library. But of course, today we are not using Kinect, but we are actually following the same principle for other RGB sensors as well. But of course, now we have some newer library that give us a workable solution for the sensor. So all the sensors that when we choose any sensor, I think you are safe to say that there are already the driver solution in ROS available for you. For example, like if you are using a webcam, USB camera, so no matter what kind of webcam and USB camera, I think the ROS USB camera, which is down there, USB camera, this ROS package will cover almost all the USB camera that I have experienced before. So basically using this package, I already like run a lot of USB camera, and yeah, most of them work. Unless you have very unique, how to say, unique sensor that it come with very unique driver, then you might need to be more careful. But a general use USB camera, it work with the same principle, and it should come with a standard driver. Okay. Then, of course, like for example, in this case, we are using the Astrea, so we need to set up the Astrea sensor, which is we already have that package in ROS as well. So if you are using, for example, like Intel RealSense, you need to use the Intel RealSense ROS package and so on. But I quite confident that if you are using popular RGB sensor, you should be able to find the equivalent ROS driver. Okay. So unless you are using something very unique, yes, we can discuss during the Q&A time to see if you are able to use the sensor in this application. Okay, but so far I think should be okay. So later you can use our example and try with your USB camera and see if it works. But please be careful that sometimes some integrated USB camera or integrated webcam on your laptop might be a bit more troublesome. Okay, usually the one that you buy separately, that plug USB, that one I think out of 10, about 9 cases is no problem, right? So one and the last one is you need some setting and it still work. But for integrated USB, integrated webcam that come together with your laptop, sometimes it requires special driver. Especially when you switch to Linux, then you might don't have the special driver that come together with your laptop for your camera. So this kind of cases, is either you find the appropriate ROS package or appropriate driver that can drive your camera, or you just get an external USB camera. Okay, it's very cheap. I mean, like in Malaysia, it's about less than 20 bucks. So it's very easily to get this USB camera to work with. Okay. Right. Okay, so these are all the packages, and also you need the driver for your camera. And then one more library that I want to introduce you here is the Opencv Apps. This one. Okay, Opencv Apps. And I'm going to open this to show you this. Okay, so if I can copy this. So I can sorry, this is not I need to go to the GitHub. And then I'm sorry. If I know Opencv, is it? No. I don't think. Okay, let me search. I cannot remember the. It's ROS Opencv. Sorry. Apps. Okay. Okay, so this one is something that I will like you to have a read. Okay, so this page. right? So we are using melodic and over here. So, okay, why I introduce you to read this Opencv app is because, sorry, I need to switch this Opencv wiki.ros.org/opencv apps. Okay. Okay, so this one. Okay, so I particularly want to introduce this information to you is because like it is very useful to use this ROS package. Okay, so this ROS package actually give us some very convenient tool to work with Opencv because you don't really need to write everything from scratch. Okay, so it already come with a lot of examples. Okay, still very small, make it bigger. I hope you can see. So it got like, for example, edge detection node, edge detection type, for example, like edge detection. So for those that do Opencv, you know, like this one is very useful for you to detect the edges in order for you to do some image processing stuff, right? Then structure analysis node. Okay, this is also very vision based if you do this kind of thing. Then also got very ready to use application. For example, like today we will introduce you the face detection, face recognition, people detection. And then if let's say you want to do some tracking, so you got the cam shift, the good features track, and so on, IK flow and stuff, right? Then the object segmentation and histogram and stuff, right? And you got all this filter as well. You want to change it to RGB or HSV and so on, right? So these are all the example that's already okay packaged nicely inside there that you can run directly. You don't need to write the code. The code is already in there that you can run. So all you need to do is you just need to read the ROS topic that is available, the result especially. For example, like face recognition, you can get the face result in ROS topic. Then you can straight away do your development by subscribe to the result and do your whatever application. So this will be very useful because it already give you all the apps that most of you will want it, okay, in your application. And you don't need to write everything from scratch. Especially sometimes this code, if you write, for example, in Python, it might be not optimized. Okay, because like the optimized one usually is written in C++. So yeah, okay. So that's why I recommend you this Opencv apps in this class so that you can kickstart your development. Okay. Sorry. Okay. So let's come back here. So this Opencv apps, something you can read further, right? And then for those of you who like to work with multiple sensor, okay, especially for example, like in Jupyter Robot, we have actually two Astrea, so one at the bottom and one on on top. Because why we have this arrangement is because like the sensor down there can use for navigation and also can use for object detection, for example, obstacle avoidance, right? Because you need the sensors to be at the lower level to see the ground, to see something that might obstruct the movement of the robot. Okay. Then you need another one which is on top of the robot to look at the to interact with the user, human, and also for your arm to do manipulation. Because you need for arm to do manipulation, you need a sensor that on the top to get the whole view, so that the robot can see the arm and also the object in front. So that's why you need these two settings. So if you work with multiple sensor, then you need to know how to do the configuration in ROS. So in order for you to have two different type of two different set of topic for both camera 1 and camera 2. And over here we have one example for Astrea because like we are running with two RGB sensor Astrea. So you can refer to this example to see how you can work with other sensor. For example, like if you have two real sen, yeah, you can. The working principle is very similar. Okay, you need to specify the ID so that when you run, it know which device refer to which ID, because like each sensor will have its own ID, so to differentiate that. Okay, so this will be the example that you can refer to see how you want to set up like multiple sensor. Okay, you can have more than one. Okay, so finally, the last 15 minutes. Okay, we are going to do the hands-on for the first half. Okay, so in order to do the hands-on, okay, today I can't really use the virtual desktop. It's because the virtual desktop cannot connect to, it's currently not support local camera. Okay, it is very different from it is not the same as the sound, which is it can actually tap the local microphone, but for the camera, currently it's not support. Okay, so I have to use the robot. Okay, so I have my robot over here, so I'm going to switch over my screen. But before I switch over, let me explain the concept first. So in order for us to get the data from the sensor, okay, first we need to run the sensor, of course. So over here we say bring up. So it's very similar, like if in last week we run the, if you still remember, we have the sound play node, right? So you bring up the sound play node, then it's ready to say something. Or you run the LM or you run the KWS. Basically, you just bring up the system so that it ready to serve you. Okay, so over here we need to bring up the camera, and I already put down several example. If you are using USB camera, then you use that USB camera ROS package that it will bring up your camera. So bring up a camera means it will bring up the node, and the node will start to collect the data from the sensor and publish the data to a certain image topic. For example, over here, and it is not just one, but several topics. Later, I'll show you the example of topic. Then for USB, not just USB camera, but if you're using Kinect or using Astria, you can use, yeah, the relevant ROS package driver. Or multiple Astria, we have one example, which is we written in RC Home Edu Vision package. Okay, so these are the examples. So it depends on what kind of sensor, which is, I think most of you are using the USB camera, then you are going to run the first one. Okay, if you run the first one and you face any difficulty, feel free to talk to us after this. We will have a Q&A, so we'll have a break. Then yeah, talk to us and see if we can help you to troubleshoot how to actually make your, how to get the topic or how to get the data from your USB camera. Okay, then down there, we want to display the RGB or depth images. So this one is to display the data. Okay, and you know, like USB camera, we only have the color data, which is the RGB data. So over here, the topic is USB cam image raw. Okay, so this one is depends on the topic. Later, I will show you, like when we run, we can ROS topic the list, and we can see what are the topics that's available for us. And for Astria, of course, we got two types. It's either the RGB or the depth image, which is give you the distant data. And for the multiple Astria is to show you, like we group this topic or this output into different set of, for example, camera top and camera. Okay, so these are the different. Okay, so I'm going to show you the example. I'm going to run the hands-on here. Okay, so I need to switch the camera, switch the display. I'm going to switch the display. Okay, and I will switch the display to zoom. Okay, so now you have my display over here. So I'm using a Teamviewer and currently connect to my robot. Okay, so I'm using the Jupyter robot, so I have the robot with me here. So when I connect to my robot using Teamviewer, so this is Teamviewer, so I'll have the user interface just like what just like what Jupyter Robot showed you in the previous week, right? Okay, so this is my robot. Okay, so I need to run this, and also I need to show you the slide, right? Okay, let me show you the slide here. Okay. Right, so I turn on my terminal. Okay, wait. I think this one. Okay. Yeah, because I remove my keyboard, so sometimes this appear, but it's okay. Right. So where am I now? Okay, over here. Right, I hope you can see. It's a bit, if the font is a bit small, you can look at the slide directly from Robot for All. Okay, so in order to bring up, I'm going to do ROS launch, and then I'll see home, vision, and then multi-Astria. Okay, but before I run, let me show you the topic first. Okay, to see. Okay, so for example, like now, if I do like ROS topic list, I have nothing. Okay, I don't even have ROS running. So there's no topic and nothing is running. Okay, so when I launch this, so I just do one launch. So always remember, when you do launch, you no need to do ROS call. Okay, because ROS launch, if your ROS call is not exist, it will launch the ROS call. Right, so ROS launch will help you to run the ROS call as well. Okay, so when I run this, okay, so I actually run two sensor. Okay, so there are long lists over here, which is I can show you over here. So now if I do my ROS topic, I actually have a lot over here. Okay, wait, let me plug the mouse or keyboard. I don't have the keyboard. Sure, this is okay. Right. I hope this one. Okay. I hope this get rid of the virtual keyboard. Okay. So over here you can see this. These are all the topic that is not to say generated. Is the output from the multi-Astria. So from here you can see two sets. First is we have the camera. And then down here, we have another set, which is, you can see a lot, camera top. Can you see? Over here, starting from here, we have camera top. And this set and this set, they are actually identical because we have two identical Astria. So it gives us two identical set of output. And you can see a lot. It got the RGB, it got the infrared, it got the depth register, and also the depth. Okay, so one is the process and one is before the process and so on. And then you can see like image raw and image rectified. Rectified means it used the camera info to rectify the image so that, for example, like you don't have the fish eye effect and so on. So it's calibrated. Okay, so these are all the topic that we can get from the ROS topic that we can get after we run the driver, which is the bring up. Okay, so we just run the bring up and then we can have this. And this one basically is already the process sensor data, the sensor data that we already can use. So yeah, we don't need to do anything. We just run this and we are ready to go. So with this step, we are already like, so once you have set up everything, you already have the data. So the next thing is what to do with the data. Okay, so but before we jump into processing the data, let us examine further the data. Okay, so over here got a tool that we can use to see the data. Okay, to check the data. For example, over here, so if you are using USB camera, make sure that you run this line. Okay, not this line. Okay, so you make sure you run this line, which is the camera ROS launch, USB camera test.launch. Okay, so this one. Right. So in order to examine or to check the output, okay, so we'll run this. So because I'm using multiple Astrea, so I'm going to use the last two. So ROS launch, ROS run, image view. So image view is another standard package in ROS that used to view image. Okay, then we use the node image view. So although it might seem to repeat, but it means the package name is image view and the node name is image view. And then after this, we need to remap the image topic. We need to tell what image topic we want to see, right? So we want to view, right? So over here, we need to get one line from, sorry, we need to get, we can see one of this, okay? We can see one of this. So I'm going to see the color one, which is, if you refer here, is camera. Then, sorry, camera, then, camera, then RGB, then image raw, right? So image raw means the image, sorry, typing mistake, image raw. So if you type wrongly, when the topic is not exist, it don't give you the error actually. It will still run, but it will wait for the topic, right? So it will never appear. So if if nothing appear, means most of the cases you type the wrong topic, okay? Right. So from here you can see, yeah, I have my robot, which is this one is the camera, okay, camera. So it is actually bottom. So I have a stool in, I have a table, a small table in front of my robot. So it actually see the leg of the table, the small stool actually. Right. So this is image RGB, right? So if let's say I run instead of camera, I run camera top, which is another set of another view from another camera, and the rest behind are the same. So I get something like this, right? So this one is actually the higher camera, right? The higher camera, but it don't really see anything. Let me pull it down a bit so that you can see. I have another thunderbolt there. Yeah. So this one. So you can see if I pull it back a bit. So down there is the table, okay, the stool that I said just now. So just now you can see the leg, which is the lower part, and now is the upper part, because I have two sensor, one below and another one on top, right? So this is the configuration of the Jupyter robot. Later you can see when Jupyter robot show you the real robot, okay? Right, so I have, so this one is the, so I put my hand in front of the camera, you can see, okay, so this is the color image, okay? So now let me show you how it looks like if I use the depth register. Okay. Yeah, so this is the distant value, but it put in like the image form, which means every point it gives you the how to say, the grayscale value, right? And then the nearer one is black, and the further it goes, it becomes white. So you can see like this part, and this part, okay, this part and this part are actually further. Okay, so this table is actually in front, and then this I have a door behind, so it's actually further. So that's why it's white, right? It's brighter in color. So, and if I put my hand in front, then you can see like it's very dark because it's very near to the camera. Okay, so this one will give you the set of, yeah, the value. Okay, so I have this value. Okay, so if let's say you want to see like how the leg look like, okay, so I just delete this top. Then you can see, yeah, this one. So just now you can see the leg right in color. So this one is the distant image that's taken from the camera below. Okay, so these are the comparison data, but of course if you use RVs, you can see things in 3D. Okay, so let me show you something more interesting. Okay, right. Okay, so this one is not in the note, but I think it's interesting to show you. So I have this. Okay, first I need to run okay, so I need to run the Jupyter robot, but it's okay. Let me run the Turtlebot. Okay, so as Turtlebot and Jupyter robot, they are compatible with each other, so they actually they can run on very similar packages. Oh, sorry. Okay, sometimes my robot just not working. Ah. Okay, good. So it's running now. Right, so let me show you this. This will be more interesting. ROS launch, sorry, Turtlebot RVs launcher view robot. Okay. Right, so this one looks more interesting because you can see things in 3D. So I'm using RVs, another way to show you the sensor data. Okay, but this time, when I show in RVs, I can see the data in 3D. So just now, oops, I think my Turtlebot just died. Okay, back. So I think my cable got some problem. But anyway, okay. So I hope the sensor data still okay, still in one piece. Okay, right. So over here you can see, for example, like if I turn on the image, I have the sorry. Okay, so I have the leg, right? Okay, so this is the sensor below, which is like this. Okay, so this is a sensor, and then Jupyter Robot actually have another sensor on top. Okay. Right, so this one is from the bottom, but what I want to show you is the point cloud. Okay, so let me do like this. Like, okay, how come my mouse is a bit sticky? Okay, yeah, okay, right. So if I turn on, for example, what is the laser scan? Okay, let me show you what is the laser scan. Okay. Okay, so laser scan is basically it convert the distance in one plane into a laser scan. So this one, it actually mimic to give us the laser scan by using the RGB-D, right? And then just now, if you look here, if you compare, I don't know why my mouse is acting like this. Okay, but anyway, ugh, something wrong with my mouse. Okay, right. So you can see I have a wall over here. So this laser scan actually gives me this value. Can you see? This value, this value. Okay, so this is the laser scan. Right. So instead of show you the laser scan, okay, so let me show you for example, the point cloud. Point cloud. Right. So point cloud is you can see point cloud. We have the colorful thing, right? And then you can see the orange one. So the red color or orange color is the nearer one, and then the blue color is the further. And you can see the black color part. Okay, so this black color part or this what we call the empty is basically the part after the solid. So you can see these two. So it actually blocks. So you cannot see the point cloud after that, right? So it makes sense. So this is actually the shadow, okay, but not really shadow in terms of light, but in terms of the point cloud. So you can see this color actually gives you the depth of the depth of the value. Okay, but of course, this point cloud might be not look so interesting. Over here, we can actually merge the point cloud and also the RGBD, RGB color. So for example, if I do like this, if I turn out this registered point cloud, then you can see now I have the actual color that is on the point cloud itself. So I have something like, you know, if you can recognize this is the lake. So this is the lake. So we have the color, and it also represent at the 3D position. Okay, so RGB-D. So D is in terms of X, Y, Z. So we have the X, Y, Z, for example, a particular point, and over there the color is brown because of the table. Then it become like this. So you can see the brown color over here. So with this, we can actually see the 3D representation with the actual color, right? So this is a very rich and very interesting data that we can get from RGBD. That with this, not only we can see the color, but also we can see the shape. And this kind of combination will give us a lot of information in order for us to do object recognition, right? So these are all the very interesting application, and yeah, I hope at this point you appreciate the representation or over here you can see how powerful is RViz playing the part for visualization. So these are all visualization of the sensor data. So these are all visualization of sensor data. You can see it gives me very accurate the wall color and also the color of the furniture over here, right? Very simple. So this is not, how to say, this is a 3D representation. Okay, so I'm done with all this. So I'm going to close this. Okay, so we are going to do the next thing. So let me turn off this. Okay, so now I still keep my sensor driver. Okay, why? Because I want to do the next thing. Right, so the next thing is I'm going to take a photo. So so now with this, I already like bring up the sensor. So after you have bring up the sensor, the next thing is as long as you can save one of the frame, basically that is how we take photo. So which means we save one of the frame of the sensor data into a picture, into a file, then it become a picture, right? So just now, if you still remember what my robot see, okay, so now let me run this example to show you the photo taken with this method. Okay, so over here we have two examples. One is what we call the takephoto.py. Another one is the takephoto sub. So takephoto sub is the similar to takephoto, but it actually subscribes to a topic, which is over here. It called the takephoto to wait for a message in order to take the photo. Because if you run the takephoto.py, it will directly take. At that moment you run, it will save that frame. But if you use this takephoto sub, it will wait. Okay, it will subscribe, it will listen to a topic. Then when you send a message, then only you will capture the frame. Okay, so they are the different. But before you want to run this example, I want you to have a look at the code first. Okay, so raw CD, I go to my this one. Okay, and then over here we have, okay, so we go into the script, right? So we have a few examples. So we want to see the take photo. Okay, takephoto.py. Right. So in this example, okay, important thing that I want to show you I want you to take notice is this one, the image topic. So if you are using the USB camera, you have to change this topic into this USB_cam/image raw. Okay, because this is the image topic that generated when you run your bring up for your USB cam. Okay, but for me, I can use this camera top or camera because I'm using the Jupyter robot. Okay, so over here, for example, if I don't change anything, it will take the camera. It will take the image from the camera top output topic. Okay, right. So for example, like if I don't change anything, okay, and then if I don't change anything and I run it, okay. So if I run it, it will be how to run it. ROS run. I'll see home vision take photo.py. Okay, so if I enter, right, then it says save image in that. And where is the image? It is actually at the current directory. So the current folder, if I run over here, you know, is at the home right over here. So I have this one. Yeah, so this is my image. Right, so this was taken from the camera top, which is, you can see like this is the robot arm, this is the microphone, and then this is the table and also the object in front of the robots. Okay, so this is the image. So if let's say I use the camera sub, okay, if I use this one, then nothing happened. You see, it just wait. Okay, it just wait. And all I need to do is I need to ROS topic, okay, list, echo, publish, not echo, publish, -1, and then take photo. Okay, then I say over here, take photo. Okay, so once I enter this and I go back here, sorry, this one. Wait, this one, which one? Yeah, then you already save another photo. So over here, I have 2. Can you see? So it actually wait for my timing. Okay, so which means you can like, okay, wait for my voice command. For example, if you combine the voice command from the last week, you can use this sub. So you can make your, for example, the Google speech recognition to send the take photo, this take photo word, to send to this take photo topic, then this example will take photo for you, right? So with this, you can develop a simple robot that can help you to take photo when you give the voice command. Okay, so that's a very interesting thing to do. So I hope you can design this kind of interesting application after this, which is you just need to use this code run and then put your subscriber, you just need to channel your LM or KWS or your Google speech recognition. You just need to make the topic and this one. So which means whatever output from the Google will actually channel to this take photo topic. Then yeah, that's all. Okay, so with this, I already like finish this part. And for the assignment is set up your camera system for development and then verify your output. So which means I don't know which camera system you're going to use, whether you're using a USB camera or you have your own Rgbd sensor, you can set up. Then you set up the appropriate driver, the ROS package, whether you're using Astria, you're using Kinect, or using RailSense, or you're using USB camera. Okay, set up that thing. And then you bring up and show what is the example, what is the output. Okay, what is the ROS topic, whether you have the camera image raw or RGB image raw or something, then you can show the picture as well. Then take the photo with voice command. As I said, you can use the take photo sub and combine with your speech recognition example. Then you can have a voice command take photo robot. Okay, right. Okay, so this is the assignment. Right, so I have done for today, for the first half, I already like a bit go more than 1 hour, but I think it's fine because like the next part will be very easy after you able to set up your camera, because the next part is basically to show you more example of the Opencv and so on. Okay, so up to this point, and I think I'm already done. Okay, so the next thing I want to do is I want you to tell me whether if you're able to set up your camera or you have some difficulty. Okay, so I would like to take a 5-minute break. Okay, so if you want to go to break, yeah, it's fine. And I would like to use this 5 minutes for Q&A. Okay, so now I would like to invite my local committee member to actually briefly explain what assignment and also the things that I say. And also I would like to ask the audience to see who has problem or who actually has set up your camera system and is working. I just want to know whether if this is okay for you to do the thing. Okay, so for you, please set up your system and share with us if you have problem, or share with us if you success to set up your system. And you can ask us question even in Thai. Okay, so can I like invite my local Thai committee member to actually ask the audience if, let's say, just summarize what I just said just now and see if they able to set up their system.
Hi Jeffrey.
Yes.
โอเคครับทุกคนก็สำหรับวันนี้ตรงคลาสตัวนี้เนาะก็คือเขาเน้นไปในส่วนของการดูข้อมูลนะครับจากเซ็นเซอร์ต่างๆเนาะไม่ว่าจะเป็นการได้ภาพจากกล้องการได้ point cloud จากในส่วนของกล้อง3 มิตินะครับก็ตอนนี้เนี่ยเขาก็ให้ assignment ไปเนาะก็คือไปลองเซตอัพนะครับกล้องของท่านเนาะกับตัว ROS แล้วก็ลองรีเช็คตัวภาพนะครับว่ามันออกมาครบหรือเปล่านะครับถัดไปเนี่ยก็ให้เอาไปรวมกับคลาสที่แล้วที่เคยเรียนมานะครับก็คือในส่วนของการใช้ voice command เนาะในการถ่ายรูปนะครับก็สามารถที่จะรวมกันเนาะแล้วก็ตามที่เป็นมี example ให้ก็คือ take photo sub นะที่เขารันตัว Robotics Hub เมื่อกี้ให้ดูนะครับว่าให้ take photo เนาะแล้วก็ให้อัพขึ้น GitHub เหมือนเดิมนะครับแล้วก็เขาฝากมาสอบถามว่ามีใครที่แบบมีปัญหากับพวกกล้องหรือว่าไม่สะดวกที่จะทำพวกเซ็นเซอร์อะไรประมาณนี้ครับที่แบบอาจจะไม่ได้มีเซ็นเซอร์อะไรประมาณนี้ก็สามารถที่จะลองยกมือถามได้นะครับเผื่อจะมีทางออกมีอะไรให้เนาะส่วนใครมีคำถามอะไรก็สามารถที่จะสอบถามขึ้นมาได้เลยครับโอเคเจฟฟรีย์
Right. Okay. So yeah, I hope for some interaction. So any of you success to set up your system and able to see the camera output? I don't know what system you are building, but yeah, you're able to see whether you are using a dual boot or using your virtual machine. Yes, I think they all. I mean, virtual machine. Yes, you can still configure your virtual machine to connect to your USB camera. It is very, very possible. We have done before. So, and then you run the bring up the USB camera driver, then you're able to see the data from your USB camera. Or you have your own Rgbd sensor. Yes, feel free to share with us. Anyone in the audience that able to set up your system? Or when you set up your system, you have some problem or question. Yes, feel free to ask us. Any one of you can interact with us about your development? Anyone? Anyone from Malaysia? Are you working on some system? I want to know like what have you achieved up to this point? Is there anyone? Or you are lost, okay? And you don't know how to set up, or you don't know what you're supposed to do. Also, yeah, feel free to talk to us. I will take like a 5-minute break to interact with you so that I hope you can work together and also we can do the hands-on together. Anyone? I have quite a number in the list. And I saw names that already come several times, so I believe you follow this class and yeah, you have done something. Right? Can you share with us
Okay,
like what you? Yes. Hello.
Hi, Doctor.
Hello.
Actually, I still start at installing the for the camera package.
Okay.
And then if I want to use laptop camera, which should I build the USB camera?
Yes.
I mean,
So
for the package.
yes, if you are using your laptop embedded camera, there are chances that the USB camera package may work. Okay, but there are also chances that it may not work because it depends on whether if the driver is compatible with your embedded USB laptop camera. Okay, so this one I'm not sure.
If cannot work.
Okay, if cannot work, then I would like to know what is the situation. When you run, what kind of error you get? If you're convenient to share your screen.
Because I'm now using my phone to connect to this.
Oh, okay, right.
And then I'm working on my laptop.
I see, and, okay.
For the Astra, I also installed the Astra, but I can't launch.
Yeah, because you need the Astra sensor for it to work. The Astra package is for the Astra sensor. So if you're using a normal USB camera, then you're supposed to use the USB camera. But the USB camera, yeah, usually it works with external USB camera. For internal one, sometimes it's not so straightforward because internal camera might require some different driver. So first thing is, okay, so when you run can you actually, okay, so in your Ubuntu, you actually have a software that can see the view cam. Can you use the software to actually view your camera? If I'm not mistaken, I think it's a cheese or something. I need to check what kind of software. I can't really remember. I think it's cheese.
I have to install that software.
No, you don't need. Okay, so if you look at my screen, right? So I just run this cheese, but because my robot actually don't have a normal USB camera, so no device found. But if you have a normal USB camera, you should see something here. Right. If you don't see anything with your camera on, then that means most of the cases is your camera don't have or you haven't installed a Linux driver for it. Okay, I understand you might be running Windows and your laptop actually come with the Windows driver, but for it to work under the Ubuntu system, you need the Linux version of driver. So one way to verify if your system able to see your camera is to run this what we call the cheese. Yeah, but your microphone is actually having very noisy environment.
Oh, sorry.
Background. Yeah. Okay, so yeah, if you run this program and if your camera is appropriately installed with the correct driver, then you should be able to see your camera fit over here. But of course, my robot don't have a USB cam, so that's why it don't have anything here.
Also, I have to check whether my Ubuntu connected with my camera first.
Yes. So the first thing you need to check is you need to check you are using VMware, right? Or VirtualBox. So if you're So if you are using VirtualBox or VMware, you need to check the setting to make sure that you enable the USB device.
Okay.
Okay, so that your VirtualBox or VMware have the access to your USB port. or your webcam. Okay. I'm using VirtualBox before, so it got the option that I can turn on my internal webcam for my VirtualBox. So I have the option. So once I turn on, then my VirtualBox will able to access my webcam.
Oh, okay.
Yes. And once you enable that, then you run this software, which is the cheese, in your Ubuntu. Then you're supposed to get your camera feed in this software. And once you can see it, then the chances for it to work with ROS is almost there.
Okay.
Okay, so before ROS, you need to solve all the preparation first. Make sure make sure your VirtualBox able to access your USB, and make sure your Ubuntu have the driver. So these are all the fundamental things to make sure everything is already there, is in place, and is working. Then only you check the ROS part. So at this point, you don't need to check the ROS part first. You check the external thing first.
Okay.
Okay. I think whatever that you just asked might be applicable for many of the audience as well. I think like many audience also face the same problem, I guess. Yeah. So you need to check one by one. Okay.
Okay. Thank you, Doctor.
Yeah. Right. Any more other audience that have any difficulty connecting to your camera? Feel free to interact with us. Yeah, because by discussing your case, okay, you can ask in Thai. I can't read your name because it's written in Thai.
Yeah, sorry.
Okay.
I need to share my desktop.
Yes,
That
yes.
when I run the command, it
Okay.
have some error like this.
Please show us USB. Oh, okay. It's neither a launch file. Do you have your ROS? Have you sourced your ROS? Because it seems like, okay, can you run the ROS call actually?
Yeah, I already.
Okay, you can run ROS call, but you cannot run your package. That means you didn't add your workspace. Have you sourced your workspace? I actually can see your workspace up there.
Can I use this command?
Yes. Correct. You run again. Okay, so now I want you to, okay, you type ROS launch, and you need a space after the ROS launch. I think it's typing error. Yeah, you type ROS launch, launch, LAUNCH. You can tap and it will come out. Then space, USB, yeah, no, space, then USB.
Yeah.
USB, then tap, it should come out. If you already installed. Have you installed USB cam?
No.
Oh, okay.
Yeah. I already plug to the USB.
No. You need to install the USB camera package.
Oh, I don't have.
Okay.
How
So
can I do?
if I'm not mistaken, should be okay. You sudo, you just type. I'm not sure if there. You sudo then space apt space install space ROS space dash not space dash melodic DIC dash USB dash cam. If I'm not mistaken, should be this one. Okay, you enter and you see if it's worked. Yeah, type your password. Okay, yeah, you haven't installed. Install this. So you need to install the USB cam, right?
Yeah.
Okay, just wait for a moment. Right. Okay, run.
And then launch again.
Okay, make sure your camera feed is okay to view.
Yes.
Okay, right, enter.
Yeah,
yes.
Good.
Yeah, right, good. Done. Okay, congrats. Okay, so you just
Thank you so
installed.
much. Thank you so much.
Okay, right. Okay. Okay, any more? any more any more person that can that would like to share with us your setup? Okay, so you see it is totally possible. You just need to install the appropriate software and it should work with your camera, but you need to solve a few things, okay? Right, so you need to solve a few things. Okay, let me share my screen.
ขออนุญาตสอบถามเป็นภาษาไทยนิดหน่อยได้ไหมครับ
Yep, you have any question?
ขอถามเป็นภาษาไทยนิดนึงนะครับ ก็คือว่าผมเคยได้ทดลองใช้กล้อง Asta กับลองใช้แล้วนะแล้วก็ภาพเดฟใช้ได้ภาพ IR ใช้ได้แต่ว่า RGB นั้นมันเหมือนว่าไม่เจอภาพนะครับมันต้องมีการตั้งค่า Product หรือว่า Vendor อะไรในไฟล์อะไรหรือเปล่าครับเพื่อที่จะใช้ RGB ครับ
กล้องตัวไหนนะครับ
Asta Camera ครับ
อ๋อครับเดี๋ยวผมลองถามเขาให้Jeffrey he want to ask that he used the Astra camera
Okay.
and he can't find the RGB image but he can use the depth image.
Can you show me your topic? Is it okay for you to share? Yeah, is it okay to share the screen and show me what exactly happening?
สามารถเปิดโชว์ได้ไหมครับหรือว่า
ไม่ได้แล้วครับเพราะว่าผมไม่ได้อยู่มหาลัยแล้วครับ
Jeffrey he cannot show now because
okay,
the
all right.
camera is at his work.
Okay. So it's strange that if you can see the depth image but not the RGB image. But one thing to verify is first when you bring up the camera, you make sure you check the topic and all the topic exists. For example, the RGB camera RGB image raw, and also camera depth register or depth, and then image raw, and just now I show you the whole list. Make sure you have the whole list. And if that is something not correct, then that means maybe the Astra package that you install maybe not correct. And then you might want to check your USB connection. Make sure your USB plug directly to your, because I don't know what is your setting, so make sure your USB plug directly to your computer and the connection is, everything is okay. And if all this thing is okay, then the only thing I can see is I need to check when you run your Astra, the log. Okay, there if you remember when I run my Astra, we actually got a lot of log coming out. So I want to see if there's any error over there. Okay, so yeah, anything red you need to be noticed, and also you need to check if, because I also afraid that it's either your Astra package not correctly installed or your sensor might have some problem. Okay, this one I don't know how to tell you unless I see your log. Okay, but these are the things that you can check. Okay. Can you please explain in Thai?
อันนี้ได้ไหมครับหรือว่า
ได้ครับ
ก็ที่หาไม่เจอนี่คือไม่เห็นใน ROS หรือว่าเปิดด้วยกล้องธรรมดาก็ไม่เห็นนะครับ
เหมือนเปิดใน RVIZ ครับ RVIZ นะครับแล้วก็มันมีให้คลิกนะครับว่า RGB แต่ว่ามันเขียนว่า no image ครับแต่ว่าที่เหลือมันขึ้นได้เหมือนว่าไม่แน่ใจว่าเกี่ยวกับในไฟล์ asta.launch อะไรไหมที่จะต้องไปดูเลข vendor คืออะไร product คืออะไรแบบนี้ครับ
Jeffrey he asked that in the Astra.launch they have some vendor ID or the product ID this
if you only have one Astra, you no need to specify the ID. It's because if you run the original in front of me you can see if you are using this ROS launch Astra launch then Astra.launch, if you are using this, it will automatically select the first one that it discover from your USB port. So it will automatically find your Astra. You no need to specify the ID. You only need to specify the ID when you have multiple Astra. So you need to tell the system which Astra belongs to which camera. Okay, so if you only have one and you are running this Astra.launch, you no need to do any setup actually in terms of the ID. Of course, you can set up the ID to make it like specified, but the problem is when you swap or change the Astrea or you change your USB port, it might affect. Yeah, it might affect the software to find your Astrea. But if you only have one Astrea, you no need to do any setup in terms of the ID. It will automatically search your USB port for the Astrea, unless you have some very complicated USB connection. Do you have like you put the Astrea after several USB hub, for example? Do you have this kind of condition? I'm not sure if you
เชื่อม
understand me.
ต่อ
Yeah.
โอเค I will translate for him.
Yeah.
ได้เชื่อมต่อตัว Astra นี่คือเชื่อมต่อโดยตรงกับเครื่องหรือว่ามีการผ่านเซิร์ฟเวอร์หับอะไรต่างๆนะครับ
เชื่อมต่อโดยตรงครับถ้าคอมพิวเตอร์มี USB camera แล้วก็ต่อกับกล้อง Astra นี่คือปกติแล้วมันจะหา Astra เจออะไรแบบนี้เหรอครับ
มันสามารถที่จะค้นหาได้เจอตอนที่เรา launch ตัว astra.launch นะครับเพราะว่าAstra มันไม่ได้เป็นตัวเว็บแคมทั่วไปนะครับแต่ว่าถ้าจะให้ลอง reset เนี่ยอาจจะต้องขอล็อกที่เหมือนที่เขาว่าครับก็สามารถที่จะเอาล็อกไปโพสต์ในส่วนของกลุ่มที่เป็นอยู่ในRobot for All ครับจะมีgroup discussion อยู่ครับก็สามารถเอาไปโพสต์ในนั้นได้แล้วเดี๋ยวจะมาช่วยกันตอบครับสำหรับคนที่พอเคยทำหรือว่าช่วยเหลือกันได้ครับ
Is everything okay?
ครับประมาณนี้ครับโอเคนะครับหรือว่ามีคำถามเพิ่มเติมไหมครับ
ครับขอบคุณครับแต่ว่าคือพอมีปัญหาใดๆนี้วิธีการเอาหลอกมาโพสนี่คือยังไงครับ
ก็เอาไอตัวที่รันตอนรันนะครับมันจะมีล็อกขึ้นมาครับแล้วก็เปิดเข้าไปในเว็บ Robot for All ครับแล้วก็ในหน้า overview ครับมันจะมี class group อยู่ครับ Jeffrey, can you show him the class group from Robot for All?
Okay, so the class group. Okay, wait. I need to scroll up. It's over here. Yeah.
ครับก็สามารถกดเข้าไปในลิงก์นั้นได้เลยครับแล้วก็copy ตัวล็อกที่มันพ่นออกมาจากหน้า terminal ครับมาวางแล้วก็อธิบายว่า error ที่เป็นคืออะไรประมาณนี้ครับ
ครับขอบคุณมากครับ
ครับ Okay, Jeffrey is finished.
Okay, all right. Okay, so I guess like we have this very good interaction because like I show you exactly like what kind of situation you guys might face. For example, like just now, the first case is like if you're using the VirtualBox, you might need to check if your VirtualBox is able to access your USB port, your webcam, and if your your Ubuntu have the appropriate driver to start your camera. So these are the things that you need to check. You can use the Cheese software to check if your driver is okay. Then only you check the ROS package. Okay, so these are the few steps, right? Then for the second case that just now you see is basically you just need to install the USB cam package, then everything should work, right? Right, and then for the last case, I think maybe it's the complexity of the hardware connection, the USB. You try not to use too many USB hub. Try to plug the camera directly to your laptop and so on. So this will reduce this kind of, because Astrea software will automatically try to find the USB that accessed by the Astrea camera, but sometimes it might not able to find if, let's say, your Astrea camera is actually hiding after several USB hub, right? So this thing might happen. So you need to check. I need to know exactly like what kind of hardware configuration and also what kind of software configuration in order to help you. So if you have any this kind of problem, show me more information, the log, the error message, and this will be more useful for me to help you. Okay, right. So I already used up a lot of time. So let's go to the next part, right?